Hello, welcome to this talk. I'm going to be presenting my paper titled What Do You Experience is What We Collect? A user experience-based fine-grained permissions for everyday augmented reality. I'm Melvin Abraham, a PhD student at the University of Glasgow. So first off, our concept here lets users decide how much data they want to provide an application by showing them the impact the application has on the user experience. The AR user is presented with a prompt that allows them to select different levels of data access with an accompanying image of what the application will look like and how it will run at that chosen data access level. So I'll run you through a few examples of how this would work. So the application the user is trying to run is an app called Subtitle. It's an app that provides situational awareness for AR users. So as you see, the first level here is denying subtitle access to your microphone, and then correspondingly, the application doesn't do much. The second level, as you can see, is the minimum requirement for the application to work. The app can only tell you if sound was picked up or not by the microphone, as you can see by the symbol on this screen presenting if sound was present or not. The third level is that Subtitle is only aware of the occurrence and the direction of sound. So the app can tell you information such as someone said something and it was to your right side. And as you can see in the fourth level is that a distorted version of the full microphone audio can be accessed. So the image shows now that the application can perform real-time subtitles as long as as well as the other functionality of the other levels. And then the last option here is providing full data access to your microphone. And the difference now is speaker recognition can be performed. So if we take a look back in history of what augmented reality headsets look like in general, you tend to think of devices such as this, like the HoloLens or now the Apple Vision Pro. These headsets are big, they're bulky, and they're sometimes even referred to as ski goggles. But we're seeing advancements in this technology where the physical form factor of these AR glasses are becoming much more fashionable and a lot smaller in size. So when I'm referring to everyday augmented reality, I'm referring to glasses such as these images here. The idea is a future where people are wearing these AR headsets continuously and throughout the day, similar to how we use our smartphones. So in this paper, we make the following contributions. We introduce and evaluate a new user experience-based fine-grained permission system that we designed specifically to address some AR privacy issues. We then compare our permission prompt with the state-of-the-art permission systems across different metrics. And finally, we took the results and we discussed how to develop AR-specific permission prompts to preserve user privacy. So a future where everyday augmented reality is in use, it comes with a few problems. So the first one is that these headsets have an increased quality, quantity, and scope of data collection compared to other technologies such as smartphones today. An example of this is if you were an attacker and you hacked into my smartphone's front camera, the data is only useful when my phone's in use. Currently, my phone's in my pocket, so all you would see is blue denim. But if you perform the exact same attack on an AR headset, you would get a lot more information, such as where I am, the people who are around me, the environment. The main issue here is that the position of the headset in use is the exact same as the position not in use. And then the second thing is a feature with everyday augmented reality headsets is that they have always on sensors. The idea with these sensors are they never turn off and they're continuously collecting and processing data to augment the user's view of the world. The sensors need to have this always on capability for features such as SLAM and surface tracking, context awareness. These always on sensors are needed to allow the headset to function properly. This really becomes a problem. As you can see, the headset will see prolonged use throughout the day. People will be wearing these in multiple locations and multiple contexts. The third issue is that AR users are not aware of what data is being used when the data is being used, why it was even being collected in the first place. The way data access is handled in AR is through the use of permissions. Currently, AR devices just copy and paste permissions from smartphones, the majority being from the Android operating system. As you can see in these images, the actual permission prompts that were presented to me, the top one is from Android and the bottom one is for iOS. You can see the Android one, the permission prompt is vague, and there's a bit more information in the Apple one, but they're still hiding information such as go see our privacy policy for more information. So when we look at what normally happens when people are presented with permissions is that they can provide full data access and get the full application functionality, or they provide no data access and they get no functionality, or the app doesn't work at all. Our concept looks at a different way of doing this, of providing different levels of data fidelity and getting different levels of application functionality. Something that the user might prefer in one section and provide less data and balance the functionality they get. So our user study had 20 participants take part in a within study, and they wore the actual light AR headsets, and at the end, we ran a semi-structured interview. So we had two sets of independent variables, the permission control prompts and the application context. The context in general there was 5 of them, and they were all based on 5 realistic AR application archetypes. So the first one, as you can see, is called filter, and it's based around Snapchat, which the main sensor it's using is the front RGB camera. Filter is an app that applies filters onto other people. Subtitle is a real-time subtitle app that provides situational awareness. This was based off work from Google, and the main sensor here is the microphone. Next is AR Health. This is your classic health app, and this one is based around the Apple Health app. And the main sensors that it uses are the biometric sensors. And then there is Room Designer. This is an app that lets you design the room that you're in using AR. This is based around the IKEA app, and the main sensor that it uses is the depth camera. And then finally, it's the app called Street Nav. This is a navigation app that is based around Google Maps, and the main data that it uses is GPS and location. And then when we look at the permission controls, there was 5 of them. So the first 2 are the image with slider. That's our concept, where we provide different levels of data access along with an image of what the application will look like at that point, at that level of data access. Next is the slider without image, which is the exact same as the previous one, but just without the image to see how well the image performed. And then the bottom, you can see the binary permission prompt. This is the current state-of-the-art permission prompt used in AR. This allows a allow or deny option where you provide full data access or not. The next 2 are based on the current Android and iOS permission systems. As you can see, there's different levels of data access. You can provide full data access, or you can provide full data access for this session or no data access at all. And you can see the difference between the 2 is that the iOS one provides a little bit more information about why the sensor is being requested. So then we evaluated the permission prompt along different metrics, such as understanding the permission controls, usability, trust, privacy decision opportunities, the perceived workload, and ran rankings. In terms of the procedure, the participant wore a set of the X-Real AR glasses and then was presented with a context and then presented with the permission prompt. Once the participant configured the permission prompt, they were asked to fill out a questionnaire. And as you can see, the blue highlighted portion was repeated 5 times for each of the permission prompts, and then the orange dotted highlighted portion was then repeated for all the contexts. Once those conditions were finished, they took part in a questionnaire and then a semi-structured interview. So what are the results and the lessons we learned from this? The results and discussion go in a lot more detail in the paper, but a very high level overview of the lessons learned is that we can't treat AR privacy the same as we treat privacy in other devices. We show that there is a need for fine-grained permissions in AR. Users indicated that they wanted to provide less than full data access by ranking the slider with image as the most preferred control, with the binary and Android control ranking last and second last. The AR headsets need to move away from the current binary and textual prompts. The binary control ranked last in terms of the privacy decision opportunities. The slider outperformed every prompt with textual explanations only in terms of understanding of what data is being accessed, why the data is being requested, and the impact that will have on their privacy. And all of this without having a perceived impact on usability. Another lesson is that people do interact with the sliders and they do want to balance their privacy with their application functionality. Previous work shows that people don't tend to go back and change their permissions once they're first set. The slider was perceived as the best in providing opportunities to make privacy decisions with minimal impact to perceived workload. Participants also trusted that the slider and the iOS prompt provided accurate information, and this was due to the prompt's transparency. Participants felt that it was harder to be deceived and led them to believe that both the app and the device would respect their privacy decisions. Though a few participants did mention there could be a risk of dark patterns emerging through misleading text or clickbait images. This would lead to the app stores needing to validate the prompts and images and the slider steps are reasonable, which is already the case for the iOS prompt with the Apple App Store. The next lesson is that AR data access is complex, and we need new methods and strategies to manage it. Traditionally, privacy is seen as individual and personal. But if everyone is wearing these headsets, one person's privacy decision impacts everyone else, hence the correct decision needing to be made. The state-of-the-art current binary and the Android prompt perform poorly for user understanding and privacy decision opportunities. Both the iOS and the sliders involved creating unique prompts that already place a burden on developers. The benefits clearly outweigh the effort, as the usability and the perceived workload of the user is not impacted, but both dominate the other prompts which provide generic information. AR permission prompts need to take advantage of the full capabilities of AR. In our case, we present users with a visual image of our representation of what the application will look like. AR headsets could do so much more and offer so many different ways of immersively visualizing and explaining the permission decisions that the user is making. For example, if the user was being placed within the AR app altogether, allowing them to interact with the permissions and change the data access levels, and they could potentially see the differences in real time, or automatically managing the permissions based on other factors such as the context or the law or bystander privacy settings. The point here is that every day AR headsets have different and unique privacy considerations to smartphones. Platforms need to move away from the existing binary permission prompts towards a more fine-grained permission system. When given the opportunity, participants prefer to balance their data privacy with application functionality. And then finally, AR data access is complex, and users need much more support than textual explanations. Thank you.